Hello and welcome to the Tech Lunch Podcast, where we encourage our listeners to learn something new about tech every week. This can range from learning about new and exciting applications to the advancements in coding and technology. If you are always learning, you will always be a step above the rest. Take the time during lunch or during a break to listen and learn, kind of like a lunch and learn, but for the ears. This podcast will open the listener's ears to new and exciting technologies they may have not been purviewed to in the past. These topics will range from manufacturing technologies to data collection technologies and everything in between. Hello, I'm Nick.
Hello, I'm Ed.
And this week we're going to talk about a question that everybody has. Is to IoT or IIoT? That is the question. And the big thing is we kind of talked about it during the snack episode for Industry 4.0 when we kind of brought up the Internet of Things versus the industrial Internet of Things moving into the next generation of manufacturing. And today we're going to kind of talk about both of those. When we're talking about IoT, we're kind of talking about the things that you get around your house. So like your door sensors, your smart things, your Google Homes, your Apple Homes and stuff like that, your wearables and whatnot. But when you're talking about industrial Internet of Things, you're talking about sensors and any of the major components on a manufacturing line. So, I propose this question to you, Ed. When you think about IoT versus IIoT, what do you kind of think?
So from a manufacturing point of view, when we're talking industrial Internet of Things, we're talking about on the sensor and actuator level. We're talking about taking signals and feedback and using that data to become predictive in nature as opposed to proactive or preventive. So from my point of view, that's the big difference with IoT and Internet of and IIoT. It's probably a lot more data points in an industrial manufacturing environment as opposed to a personal aerial network with a Fitbit.
Yeah, and that to me is leaps and bounds of where we're coming from. We're coming from where we're dealing with, oh, look, something broke, but we don't have any data on it, to, okay, now I know what broke, when it broke, how it broke. And, we were talking about the personal area networks and stuff like that. It's kind of like, okay, what's your heart rate? What is your door open in your house? What's your AC temperature set to? You scream at your Amazon Alexa and tell it what to do. That is IoT. When you talk about the industrial Internet of Things, you're talking about a more robust system, but on the same principle. It's no longer Zigbee or any of the other common at-home communication protocols that are being used for the Internet of Things.
And a typical life cycle for a IIoT system is probably 20 years. In some cases, say infrastructure is probably 40 years. The typical lifespan for IoT for, say, Apple phone could be maybe 2 years. So that's the other point of view to look at. It's a lot more data points over a lot longer time, and you can take those data points and use that to, like I said, instead of being proactive or preventive, you can be predictive. So now I can predict when the machine is going to break and when I'm going to interrupt production, which means interrupt my cash flow.
Yeah, and you're kind of talking about the same thing when we're getting down to especially when we talk about time, and usage time, it's return of investment or ROI. You go from your home sensors, which run on a battery, which may be only good for a year or two, maybe a little bit more, to an IoT device, which is hardwired and built for heavy industrial manufacturing devices and stuff like that. And it also communicates via, MQTT. If we're talking about, if we're doing it that way, we're talking MQTT to like a Power BI interface and anything else you can possibly ever think of, it can flow data to one point or another.
And then we can think about it in another aspect. Say shop floor operations, supply chains, and then remote and third-party operations. The world is changing now. No one is using their own servers for everything. Things are in the cloud. We're also, it's vital that I understand the supply chain. It's vital that I understand if I'm efficient with the resources and materials I'm using to produce these products. And from a shop floor operation point of view, I want to know when I'm not running efficient. I want to know when I'm going to have additional time to produce. You would hope that that time that you produce would be within the hours that we allotted and not outside of those hours.
Right. It's good for KPI tracking and stuff like that. Understanding where you're going and where you're coming from, what your daily numbers are looking like, and how things are moving. And also, it reduces, the loss of work and, all the other type of things, when it comes down to, the KPIs and, ROI and all the other stuff. And also, you're talking about like logistical transport. You got the AGVs that are communicating via IIoT and other things like that. But now to propose a question, the big question with that is you're talking about like a football field. You have an IoT sensor or an IIoT sensor implanted in the turf. When that will trigger your your irrigation system to kick over, and when that kicks over, you're talking about an IoT or an IoT system triggering that to happen. So when you think about that, does that read IoT or IIoT?
Well, it depends on if we're talking about resources. If we're talking about the resources we're using and we're trying to track consumption, exactly, it's the same thing. We're talking the same thing. As I said, in a manufacturing environment, everything is time sensitive. You produce, just in time. So to give you a different point of view, say the irrigation system, well, everybody wants to save money. So if I have a corporation, then I don't want to overuse resources and waste water. If it's not necessary to water at a certain time, then I can be predictive when I do these things, which saves me money.
Yeah, which kind of rolls into your IIoT at that point. Because if you're talking about power consumption and stuff like that, you're talking about IIoT. If you're talking about, okay, cool, my plants are wet, let me automatically water these darn things. You're talking about IoT. You're not talking about anything that's really going to be at a industrial or collegiate level that kind of needs help.
And say from an IoT point of view, where you could kind of tie and make some similarities, if I wanted to track when, say, we were practicing on a field, and during that time I wanted to monitor heart rate, I wanted to monitor how much the guy perspired and so forth, then I can take all this data in real time and send this data to a database and have it analyzed and say, hey, at this time of the day, we were really, really efficient. However, when it was 90 degrees and about 60 degrees and about 60% humidity, we had a problem. So those are things that you can do to maximize your resources. And that's the same thing you do in an industrial environment. Like I said, you want to know when, where, and how those resources are being used.
Yeah, and funny you mentioned the whole, the bodily mechanics and stuff like that. NASA actually uses sensors and stuff like that on board the International Space Station when it comes down to the astronauts to actually track their vital signs and their sleep patterns and to make sure they're okay. And it does it via an IoT interface back to their system through satellite communication back down to Houston, back down to the control centers and stuff like that. So if you think about it, IIoT and IoT are used in a wide range of environments, be it zero gravity or all the way down to the guy on in his house trying to make sure his door's open and closed.
Right. Well, imagine, if you will, how IoT can change manufacturing. If I'm predictive, I know when, where, and how I'm going to have line stoppages. which I can use remote production control to manage these situations. I can also use asset tracking to track which parts are breaking in the system, and once again, more information to tell me, hey, this is my failure point. Then I can use logistic management to say, hey, we need to look at when we produce, say, a 5-ton vehicle compared to a 3-ton vehicle. Is it more wear with a 5-ton and less wear with a 3-ton? Those are things we should consider. And then we should, to protect ourselves for all the data we have and to make sure our system is secure, we should have a digital twin. These are things that I think will be a game changer in IIoT.
I think you're hitting the nail on the head with that one. I think that the digital twin factory standpoint is probably one of the best ideas that's came out of what is going to be Industry 4.0, because we can test without actually testing on our manufacturing environments. We know when things are going to break. We know what parts we have to order and how far we have to go to get those parts to actually do what we want them to do. And the thing is the digital twin is more robust than just somebody out there watching it going, okay, I think this is going to work.
And I agree with you, Nick. I mean, we went from having humans do every process on a assembly line to we incorporated robotics into the line. So now the robotics are becoming smarter. Now the robotics is giving us that predictive information. Now the robotics are telling us, hey, I think this path is incorrect. I would be more efficient if I ran this path. I mean, we're talking game-changing things that can be done on the fly. So I believe that if embraced and utilized the right way, not to just become another widget, IIoT could really make plants become, I would say, run like a sewing machine. Excuse my language.
Yeah, I know. The thing is, I think that, with that, we need to make sure it doesn't become a buzzword. Everybody wants to say they are Industrial 4.0 compliant because they have IIoT devices, and really, in reality, they don't. But because they're really not doing anything with it. They've got the data, but they don't do anything with it to help themselves. I think the use of IoT and IoT in any environment, be it home, away, wherever, it needs to be embraced. It needs to be understood that this is the way of the future, and this is how we have to get there.
Like I said, from a maintenance point of view, reactive means fix it when it breaks. When we say preventive, we say maintain it regularly at intervals so it doesn't break. But predictive says it's the right time, as opposed to being reactive too late, as opposed to being preventive too early. Predictive exactly tells us when it's going to break, and we can take that information, design better machines, and also I can use machine-to-machine communication so that this machine knows, hey, I'm at a point where I'm about to fail.
Yeah.
You should make some kind of adjustment, or make an adjustment, or throttle down or throttle up to make up for the time I want to be down.
Right.
I estimate the time to be this interval.
Yeah. And the thing is, if you think about it, we covered that in our snack episode where people can go back and watch that as well. But, the other thing we're talking about is with the preventative maintenance stuff, we know that we need to order parts. We have a lead time. We're not going to wait for something to break and then the line's down for 2 or 3 hours. We already have that part on hand because we knew that was going to happen, or we were able to catch it in a PM hours or days prior.
And you like I said, with the preventive maintenance, we're talking predictive quality control. We're talking profit per hour. We're talking yield energy throughput. We're talking generative design. We're talking all these type of things that we can put in place to compensate for if, in the event, we have an interruption in the supply chain. And if the line's not running, it's an interruption in the supply chain.
Yeah. And the thing is, it goes back to KPIs. Then all of that can be tracked inside of a KPI. And what gives you your KPIs? IIoT. or MQTT, depending on how you have it set up or how you're running your operation. And it also reduces the amount of hours that you have somebody out there watching something go wrong.
Yeah, because to me, I would much rather have data gathered as opposed to have someone writing down some bits of data that may be incorrect. I want the raw data so I can take the raw data and transform it into something that I can utilize. It does no one any good to have tons and tons of data that means nothing. So to me, this is it's something that all companies should look into. I mean, they should really look into it.
And now you think, when you talk about the writing things down, we've now gone paperless. So meaning that the IoT and IIoT interfaces and stuff like that, make sure that we're going paperless. So we're saving the natural resources, we're saving money on the paperwork, and we get rid of the human error of writing something down. Now, his data does not lie. And with that, you're more accurate. You're not worried about, can I read this dude's handwriting? Or this gal's handwriting? Or whatever. Was it typed up correctly? Or what happened? We're going out, we're leaving the Stone Age, we're leaving the flip phone age, and going to the iPhone age. And then we're going to go from the iPhone age to whatever's next.
And with this technology, we want to go away from the conventional made to stop. We want to go to made to order, or configured to order, or engineered to order. We want to go to actually just in time. Use the resources you need to produce the products you want to produce.
Yeah. And, the thing is with that, it's, improving, like you said, the throughput. We know that this is going to happen, so we can get that done on a weekend or whenever we're not actually actively running production. And then taking that and building on top of it. And if you think about it, when we're going to, move into like the plants of the future and stuff like that, we were talking about automated ground vehicles and whatnot. We're trying to be more proactive and reactive and actually really get to know that type of stuff. And also controlling the routes of where they go and how they get there and stuff like that.
So like I said, a simplified IIoT stack would be intelligent assets. And I would say an example of that would be, say that a problem occurs in another plant. In real time, that data is shared with all plants to say, hey, we found this bug. Data communications. I mean, at real time, you can look at how all the plants are running, what are the things they're doing to be efficient. Application and analytics. Everybody runs the same application. Everybody has the same analytics. Run real streamlined. And then the people. The people have the data and dashboards and visual applications that they can interpret what the data is saying. You take what the data is saying, you utilize that, and then that makes your operation run smoother.
Yeah. Makes the decisions happen faster. You're not really, running at the seat of the pants anymore. You're running at a knowledgeable database. And if you think about it, the big thing is with the whole, simple scales. And if you do IoT simply, eventually you'll get to a bigger set. And, that's not just from everybody else saying that. It's also like the CEO of Astra. He's the one who kind of coined the simple, scales type of mentality. And, I could not disagree with him. And if you think about it, simplicity gets us into orbit, for certain things. And with that, you're going to get IoT. And IoT, that's eventually going to move us from earthbound to interplanetary, society, and then eventually, off to Mars.
Yeah. So, and then kind of piggyback off what you said, Nick. So I would look at it this way: you have, we got the cloud, we got edge computing, and then we actually have, the data that we're sending to all these things. So I would say that with edge computing AI, we could probably have a lot of I would say the incorrect information you get. We could actually start to make the machines learn, and the machines can learn, which would make the process better.
Yeah. And AI and data lakes and stuff like that is a whole nother bag of animals. That's something that is on the fringe end of IoT. It's where all the data goes and stuff like that, and how we, perceive it into the descriptions and the decisions that are being made at management. And the thing is if you think about it, what stops a manufacturer from collecting all these issues that they're getting with the vehicles and stuff like that, especially during production, like rework and stuff like that, and compiling all that in real time and being shared with their dealerships?
And just like I said, just to kind of throttle down a little bit and give you guys a kind of overview, like I said, remote monitoring, real-time machine monitoring, predictive maintenance, production visibility, integrating systems, compiling KPIs, and asset utilization. These are all the things that you can use in any situation where you have an unknown and you're trying to find the known.
Yeah. You can't build without facts, and you can't work without parts. You can't do anything without the data that is going to get you from point 0 to point 1, and from A to B, from B to C, and C to D. That's kind of where you have to get to. And the thing is the data transfer from IoT and IIoT, and how we're actually integrating with subsystems and secondary and tertiary systems. I think that's kind of where we're going. And the big thing is with that is it's not just making the process smarter, the equipment smarter. It's making the human being smarter.
Correct. And imagine a CEO of a company. He understands that he has state-of-the-art equipment on the floor, but to him, he doesn't understand all of the mechanisms that make those things move. For him, he needs to know why. Why is it not working? Yeah. When did this happen? And which areas is this happening in? How can we make this better? How can we prevent this?
Yeah.
Moving forward, should we just stop and sit on our hands, or should we have some countermeasures? Should we have, hey, I have a counter solution. Hey, I have a workaround. All these things can be done by pulling that data. The data is very important, and you have to have the sensors and actuators to give that data back to databases, so that the databases can go into data lakes, and so that the data lakes can put it into systems that analyze, and so that the guy that's looking at the system that's being analyzed can look at it and say, okay, hey, I see something here.
Yeah. I guarantee you that a group of sensors that somebody can buy or a company can buy from a reputable manufacturer is still cheaper than downtime. It's got to be. If you think about it, if you're in a logistics, platforms, just to think about this, if your system goes down and you can't ship a package, now you have to eat cost to speed that package up to get to its original destination. If you're thinking about automotive manufacturing, one downtime equals one vehicle. So 1 hour of downtime is what, 5 or 6 vehicles at $15,000 a vehicle, roughly, on scrap cost. But if you think about it, that's still cheaper than paying, or still, it's actually more expensive than paying for the sensors. You can buy the sensors and save that time.
And I would say, let's look at production visibility, because I think here's where a lot of the information gets lost. I would say with production visibility, did we do something manual? Did we change the process? Did we work outside of scope? those things can be tracked, not as a way to punish somebody, but a way to mentor somebody, a way to say, hey, we will stick with the process. We will follow the process 100%, will not deviate from the process. And when you do deviate from the process, we'll address it. And this is another great thing that we can use industrial Internet of Things for, with the sensors and actuators and the data, because the data does not lie.
Yeah. And it also helps people find, if you have to go into manual for any reason, there's a problem. And it helps, all of that be addressed to why we're having that problem. So it might not be an individual causing an issue. It's the fact that they're noticing an issue and trying to address it, and the system isn't catching it yet, which that happens.
And then, like, one of the most important things in software development is debugging and testing. Well, in the manufacturing environment, you don't have that same luxury. You do some testing, but most of the time it takes running production for several hours, thousands of hours, before you can find a bug. Imagine, if you will, if I could listen to the data being given from those sensors and actuators throughout the whole triangle of an automation pyramid. Now I can take all those data and start using it and say, hey, here's a bug. Every time we run example A, we have this certain downtime. So if I run a 5-ton vehicle as opposed to a 3-ton vehicle, I have a lot more errors with a 5-ton than I do with a 3-ton. Yeah. So maybe now we can use this with our integrating systems to say, hey, in the future, we should consider these things equally for a 5-ton or a 3-ton.
Yeah, and the thing is, if you think about it, it's a good way to kind of see where you're at. And the thing is, that's where the digital twin comes in. You can take all that data, throw it in your digital twin, and see what happens. And then you can take all that data, times it by 2 or 3, and you get your yearly run. If an organization listens to their data for 1 year, a complete calendar year for 12 months, 365 days, you can take that data, multiply it by how many numbers you want, and you can simulate that many years of data on your system in a digital twin to see what happens.
And I also think, because we would now have access to intelligent sensors and intelligent actuators, now we could also get data that would tell us, hey, maybe this sensor is not the right sensor for this application. Maybe this actuator is not the right actuator for this application. So now we can take all this data and put all this data back into our integrating the systems, and that could tell us a lot when we're moving forward to expand lines or build new plants, or if we have another plant that's putting in new equipment, that information in real time can be sent to our planning department so they know, hey, this is an issue. This particular actuator has had a recall. Yeah. Hey, this particular sensor is known for having misreads. And also I can use that as a check. I can use it as a system check. I can do a system check with my sensors and my actuators to verify that they are working properly.
Yeah, helps us build the plan of the future. And with that, it also helps us deliver a cheaper product to the customer while still maintaining the highest level of quality, because we're not spending so much time on downtime and fixing issues. We're able to concentrate on our quality of vehicle, meaning the vehicle gets to the customer faster. If you're talking about an automotive manufacturing environment, at least. And same thing with, package handling and stuff like that. It gets the package to the customer faster. But, with that, I think we're getting towards the end of our lunchtime here. And, it's time to get back to work, back to the daily grind. So, but with that, we kind of think about this. Is it IoT or is it IIoT? That is the main question in all of this. So, I'll leave it to you, Ed, to give us our final thoughts.
Well, I think they're both the same. It's just that the utilization is different between the two. There is maybe not as big of a data consumption as it is with industrial IoT, and then the life cycles are different. Consumer electronics lasts 2 to 3 years. Industrial electronics lasts 20 to 40 years. I think that's really the big difference, but they both do the same thing. you can take data to transform your life.
Yep. So, all right. Sounds good to me. Thank you for listening to the Tech at Lunch podcast, where we hope you learned something about tech during your break or during your lunchtime. If you did, please give us a follow to prevent missing future episodes. If you have any ideas or something you want to hear or learn about, please send us a show idea to podcast@vulcanara.com. Hope you have a good rest of the day and continue learning.